In this video, we'll look at scale drawings and similar figures and how we can use proportions to help us solve problems with them. So first off, a scale drawing is an enlarged or reduced drawing that's similar to an actual object or place. The scale is the ratio of the distance in the drawing to the actual distance. So let's take a look at a problem with scale in it. The scale on a map is 1.5 inches to 40 miles. If the actual distance between two cities is 60 miles, how far apart would they be on the map? When I solve this problem, I want to set up my scale as one side of my proportion. So I'm going to write the scale, and remember to include the units, because that will help us set up the second side. So my scale is 1.5 inches to 40 miles. Well, I know from the problem the distance between two cities is 60 miles. And I want to keep my units consistent, so I had miles in the denominator here. I should have miles in the denominator on the other side as well, with inches in the numerator. So it's 60 miles, and what I'm trying to find is how far apart they are on the map. So I'll call that F inches. And then I just want to solve this proportion by cross multiplying. 1.5 times 60 is 90, and that's going to be equal to 40 times F. You can divide by the coefficient to isolate the variable. And when I take 90 divided by 4, I find out that F is equal to 2.25 inches. We can also use proportions to help us solve problems with similar figures. So similar figures are figures with corresponding angles that have equal measures and corresponding sides that have proportional lengths. So what that means is you see how angle A and B are both 120 degrees here. That means that angle W in this similar figure is 120 degrees, and so is angle X. Likewise, since angle C and angle D are both 60 degrees, the corresponding angles are angle Y and Z, so these are both also 60 degrees. And then we have the corresponding sides. So side AB, this corresponds to side WX in the similar figure. And side AC is going to correspond to side WY. So I can see, if I write a proportion, because I know the sides are proportional, I can write my proportion. I can write it as the yellow line here, A to B, and I can set my ratio up as A to B over A to C. So I'll set it up as 6 over 4.5. So the top side here to the left side here is equal to the top side of the smaller figure 4 to the left side of the smaller figure S. And when I multiply this out, 6 times S is 6S. And 4 times 4.5 is 18. I divide both sides by the coefficient. 18 divided by 6 is 3, so S is equal to 3. Okay, here's a problem for you to practice on your own. The cities of Jackson, Mississippi and Carson City, Nevada are 7 inches apart on a map that uses a scale 3 inches to 250 miles. What's the actual distance of those two cities? So remember, I want to use this scale as one side of my proportion. Inches, 3 inches to 250 miles. And I want to be consistent with my units on the other side, so I'm going to set it up as inches to miles on the other side. I see that they're 7 inches apart, so I'm going to fill in what I know here. And I want to know the actual distance, which means I want to know how many miles the two cities are apart. So I'll call this Y. And I'll solve this by cross multiplying. 3 times Y is just 3Y. And 250 times 7 is 1,750. I'm going to divide both sides by 3. And when I solve this out, I get Y is equal to 583 and 1/3 miles. Alright, let's take a look at another problem here. I know that these two rectangles are similar here, and I want to solve for W. One thing that can make this easier to set up the corresponding sides is just to rotate our rectangle so that everything's aligned the same way. And then that will help me see what corresponds to each other. So I've got the left side here, DG, right, corresponds to QR. And I have the top here, DE, corresponds to RS. So when I write my proportion, I want to write it as 18 to 24 equal to, so I did the top to the left, so I'm going to set it up on the other side as equal to the top to the left, W over 16. Now I'm going to cross multiply. 16 times 18 is 288, and that is equal to 24W. Divide both sides by the coefficient, and I find out that W is equal to 12 feet. And finally, on this last problem, in this last problem I see that these pentagons are similar to each other, and I also have to find the length of Y, and I have to find the length of M. In this case, I'm going to need to set up two proportions in order to do this, and I just want to solve for one variable at a time. So the important thing to see here is look at the corresponding sides that we know. We know the base of this pentagon here, 8 feet and 4.5 feet. So I'm going to solve for Y first. So I see that Y on the larger pentagon, it corresponds to the 2 feet here on the smaller pentagon. So when I write my proportion, I'm going to set it up as 8 feet to Y, so 8 over Y, so the base to the left side here is going to be equal to the base of the smaller, 4.5, to the left side of the smaller, 2. And then I'm just going to cross multiply. 4.5 Y is equal to 16. Divide both sides by the coefficient, and 16 divided by 4.5 is 3.5 repeating feet, or 3 5/9 feet. And now I just want to see the next one here. I'm going to again use this 8 feet and 4.5 feet, but then I'm just going to look at the top here. So this 6 foot side corresponds to the M here. So when I set up my proportion, I'm going to set it up as 8 feet to 6 feet, so the base to the top here, and that's going to be equal to the base of the smaller pentagon to M, the top of the smaller pentagon. And again, just cross multiply to solve. 8 times M is 8M. 6 times 4.5 is equal to 27. And then divide both sides by the coefficient, and M will be equal to 3.375, or 3 3/8. And that's how we use proportions to solve scale problems and similar figure problems.